Okay, continuing on with section 3.2, we have a random sample of receipts for individuals eating at the Terrace restaurant showed the sample mean to be X bar equals $10.38, with sample standard deviation S equals $2.17. Now, we're going to compute the coefficient of variation. Now, the coefficient of variation is important because if you notice, standard deviation depends on units. You know, let's say we had a group that maybe was in dollars and another set of data that is in yen. Okay, we can't compare the standard deviations and talk about whether one set of data varies more than the other. We would either need, you know, all of it in dollars, or we would need both sets to be in yen. Well, the coefficient of variation takes care of this. If we have two sets with different units, then we can look at their variations through the coefficient of variation. So the coefficient of variation, I'm just going to call that CV. That was the standard deviation divided by the sample mean times 100. When we divide here, the units cancel out, and multiplying by 100 is going to make it a percent. So we're going to take the $2.17 and divide it by the $10.38. Okay, so when I do that, I go, let's see, 2.17 divided by 10.38, oops. And I get 0.2090. We got to multiply by 100. So it goes 20.905. So I'm going to go 91%. Okay. Now, if we had another set of data and found a coefficient of variation, we would also get its percent. And the higher percent would show more variation. Okay, it'd be spread out more. And really all this tells us is that the standard deviation is 20.91% of the mean, okay? So about a fifth of the mean, something like that, okay? All right, Chevyshev's. We're going to use Chevyshev's theorem to find the smallest interval centered on the mean in which we can expect at least 75% of the data to fall, okay? This is that formula where we start with the sample mean, X bar, and we go minus, you know, something times the standard deviation, and then we do X bar plus something times the standard deviation. This percent right here, the 70%, is within two standard deviations of the mean. So we're going to do X bar minus twice the standard deviation to get the smaller number of our interval, okay? And this is the word 2. Up to X bar plus 2 times the standard deviation, okay? So our X bar in this problem was the $10.38 minus 2 times the standard deviation, which was the $2.17, okay? And then we're going to do the $10.38 plus 2 times the $2.17. So let's work that out. 10.38 minus 2 times 2.17. And this is in dollars, so we get $6.04 up to 10.38 plus 2 times 2.17 up to $14.72. So I would expect at least 75% of the data to fall somewhere between $6.04 and $14.72. Now, the only way that this problem would change is if instead of 75%, if this said 88.9%, you would have multiplied by 3, okay? If this said 93.8%, you would multiply by 4, okay? Now, sometimes it wouldn't happen in this one, but sometimes when you multiply by 3 or multiply by 4, you might end up down in the negatives, which doesn't make a lot of sense, but that's fine. You go with it anyway, even if it doesn't make any sense. Okay? Let me know if you have any questions, and good luck on the homework.